you want to say a few more sentences
Yeah,
about
yeah,
that?
definitely share more. Just
A couple more tokens, please. A couple more tokens, please.
Yes, happy to share. So yeah, my name is Daniel. I'm a UX researcher, product strategist that recently left Deloitte Digital and have been working on a concept to make a modern recipe website that allows people to substitute and for us to modify recipes based off their health needs, their cooking preferences. At this stage, I have pretty much built out the whole product strategy and have a fair amount of user stories, but just really need to find that right technical co-founder that wants to decide the tech stack and build out, the user stories with collaboration. And I'll handle the investor side and partnerships. There's a lot more, but I'll stop there.
Okay, yeah, thank you. Anyone else? I can have a brief advertisement of my team at Amazon. I am an applied scientist at Amazon Alexa AI, and our team does personalization for recommendation systems. Also, we do lots of large language model related projects. I think we are hiring for interns, but this year maybe it's too late. But if anyone is interested in future related opportunities, you can also reach out to me. Yeah, I think. Yeah.
I'll say a quick word. So Eric Henhafer, I'm a partner mentor here at Capital Factory. So if you want to hear more about Capital Factory or talk about challenges of starting up companies, we do mentoring services for free, so come and chat with me. My background is hardware engineering and ML and all that kind of stuff.
Okay, thank you. Also, we want to thank our sponsor first, Capital Factory, who sponsors our room for us, and also the Already, who sponsors some free books for us for all of our future events as well. And yeah, again, please remember to enter the raffle, and by either tweeting the hashtag #AICampAustin and the tag AICampAI, or you can comment the LinkedIn post. You can scan the QR code to get the instructions. I think that's all about the introduction, and then I will give the main time for to our speakers. So our first speaker is Jason from Latitude AI. I will let him connect to our monitor and start his talk. I'm going to try the mirror screen first.
Okay. Does it have a code there?
Let's see.
There
Yes.
we go.
If that doesn't work, I have your notes.
Oh, thanks. This looks like it might work.
Yeah.
Oh, great.
I'll just
Thank
take
you.
that
I
just in
appreciate it.
case.
All right. Hey everybody, how's it going? Cool. Yeah, so my name is Jason. I run a ML and data platform for Latitude. So Latitude is a subsidiary of Ford. We used to be Argo AI, and we got absorbed by Ford, and we're doing the self-driving for all of your favorite Ford cars that you know and love. I was a little bit kind of nervous putting together this talk, and I was trying to figure out why, and I realized there's something really profound here, and I'd love for us to collaborate together on this discussion, and people to share their stories. I think that we're kind of there's sort of a gap here where you have things like oh, my model loss function isn't right, but you don't have a lot of kind of war stories like you do for software engineering in general and best practices. And so I'd love to kind of build that collaboratively with everybody. I've done a bunch of stuff in this space, in the ML space. I used to do a lot of hardware hacking type things as well. I got in enough trouble that my wife made me stop doing that. And so now I'm working on this ChatGPT interactive fiction thing, because I thought that if I mentioned ChatGPT, then it would become an official ML presentation in 2020. But it's pretty cool. I think there's a lot of video games where you have to like kill people or step on them if you're Mario or whatever. And then I'm trying to make a game where you have to like build empathy with people to win. And so far it's pretty cool. It's coming along. You can follow me on Twitter, and occasionally I'll rant about it. So, a lot of models, you hear about fail during training, right? So here on the left we have, this loss function that's exploding, right? Everyone's kind of seen that. You set the learning rate to like 0.9 or something, you'll get a graph like that. And then on the right you have, in a situation where there's an occlusion and two cows are being detected as one extremely long cow, which is pretty awesome. But the vast majority of models fail in ways that aren't quite so fun. They'll either break down for systemic reasons. The overall system kind of spins out of control or has a gap in it. Or they'll just fail to launch because they have a bad premise. And we're going to talk about kind of both of those and what that looks like and how to sort of protect yourself for that and how to pivot around these issues. And by the way, feel free to stop me, ask any questions. Love to have kind of open conversation. You don't have to raise your hand, just yell it out. So it's important when you start, and this is true in general, but I'm going to put kind of an ML or an AI spin on this to validate the premise before you go about solving the problem. It's kind of ask that philosophical, that kind of economic question, like why are we going to spend time on this, right? And so here's an example. We've all seen kind of confusion matrices. So just to give a recap, if you do some binary classification, if you're predicting whether someone's going to answer on Alexa yes or no, then you kind of break this down into 4 quadrants. So if your model predicts they'll answer and they do, that's a true positive. The model predicts they won't answer and they don't, that's a true negative. Then you have false positives where the model thinks people aren't going to like it and they do. And then you have, or did I get that right? False positives and false positive where, exactly. You don't think someone's going to like something they do, and a false negative where it's the opposite. So when I was at Apple, a team approached me wanting to build this really smart home, and they wanted to use AI. And so they wanted to have AI open your garage door for you. And I didn't, go in such pedantic detail, but I'll do it here. But basically, if you look at the economics here, right? This is I kind of made this up, so very hand wavy. But if it's true positive, right? If it opens the garage door at the right time, you don't have to press a button. Like, what is that really worth? Maybe a fraction of a cent, right? False negative, you get to the garage, it's not open, and you have to kind of look for the garage door opener. Not a big deal, but a minor inconvenience. False positive, your house gets robbed. Someone just opens the garage door, the AI just opens the garage door while you're at work, and people just start taking your stuff, right? Now, granted, like depending on where you live, maybe there's a probability here that isn't 1. Where I grew up, this is like 1, but your mileage may vary. But either way, it's a pretty bad number there. And if you do the calculus, to make this work economically, your model needs to have a precision of 99.9999% and a recall of about 91%, just to break even here, right? And so, as we kind of explained to the smart home folks, like, we're not really, by the time we get there, like, what are we really doing here, right? So maybe we could use geofencing or something else instead of like training, a deep neural net for this, right? It's kind of making this sound kind of silly, but really, as someone who is practicing ML at your company, this is a decision that you're going to make constantly. You're constantly going to get teams approaching you to try to address different problems, and you're going to have to do this calculus to decide what to go after. Otherwise, you kind of end up in a really frustrating position. So this was another example. When I was at Facebook, I was there when we launched the Oculus App Store. And the team approached us and they said they wanted deep reinforcement learning and an LSTM, a transformer that would accumulate all of their purchases to some high dimensional latent state, and then do game theoretic reinforcement learning on that latent state. And we didn't manager ask for that. Yeah, I mean, Facebook has awesome TPMs. Yeah, very technical. They know what all the words are. So then we said, well, okay, we could build that. We were doing some similar things for other parts of the company, but why don't we start with this, like max app purchases, and that one C++ line met their metric, right? And so really what happened is, the store hadn't launched yet, and so they weren't really calibrated on how many purchases they were expecting and what a good benchmark is. And so we would have spent a ton of time on something that didn't really matter yet. Now later on, you can make the case, but always kind of start with something simple. Otherwise, you can't even build that matrix that we showed earlier. Right? So that is kind of validating the premise. Let's say you've gotten past that step. Now I'm going to walk through some systems we did build and kind of the sort of stories behind them and the lessons learned. This is an awesome chart. It's from NVIDIA. There's other ones similar to it. Kind of walks people through the whole flywheel of an ML system. The one thing I want everyone to take away is that this right here, model training, that's not the only place where there's optimization being done. It turns out actually the real optimization is right here in the middle, right? You train the model on the data you have, and that data you have is just a small window into the possible, the multiverse of experiences that you could have. This is true if you're doing Alexa, or if you're recommending apps, or you're distributing coupons, recommender systems, you're driving a self-driving car, or you're riding in a self-driving car. You're seeing a very small window of the domain. And so as you roll out new models, you're kind of shifting and possibly expanding your aperture into that window, and you're constantly in uncharted territory. So you can think of that as the real optimization. Just on the way, you have to train a whole bunch of ML models. Any questions about this before we move on? Yeah.
It's the center one. I can't quite read it. It says parameterize and monitor. Would that be the unofficial label of that center process step, I guess, or would you give it a better name, or is as a single concept like the others?
Yeah, it's a good question. Yeah, interesting. Yeah, I do feel like maybe it's a little bit superficial, right? So really what I would say ML engineers and data scientists are doing are modulating all of these boxes. Yeah, and some of them are parameters. So there's clearly hyperparameters at training, but there's a lot more than that. You can say, for example, I have a feature, I'm doing an advertising system. I have a feature, is lawyer. And then I realize that, different branches of law, respond differently in advertising. And so maybe I need to break that feature out, right? So yeah, I would say there's more complexity there, but you're right that basically you're modulating all these boxes to kind of continue to spin this flywheel. Yeah. Any other questions? So back around 2009, 2010, we started a project called Sybil at Google. Sybil ended up being really pleasantly successful. It was basically a huge linear regression. Now this, at the time in 2009, this was a lot of weights. I mean, I think ChatGPT is more than that now or something, but it's, you know, this is pre-TensorFlow and all of that. So it's a huge system, a huge logistic or linear regression. Ended up powering most of the recommendation stuff. Begrudgingly, we had to support Google Plus. We all kind of felt like, what's the point of this thing? And eventually died. We were happy. You know, Sybil, as I say, kind of predates a lot of, you know, kind of the sort of modern AI stack. So we ended up using coordinate descent with momentum. So what that means is, you know, if you're familiar with say PyTorch, you execute your model and then you call backwards and it would back propagate, right? It would do a gradient descent step along the way. Yeah, go ahead.
Would the momentum approach be similar to something like RMS prop or AdaGrad?
Yeah, exactly. So it's that kind of momentum, but we're not doing gradient descent, we're doing coordinate descent. What that means is each weight is its own brain. So each weight has its own atom, you know, momentum term. And without that, they would all, you know, overcommit. Like every single weight would say, oh, I need to be X to make, you know, it's a linear function, right? So if I'm exactly X and nothing else changed in this 100 billion network, then we would be perfect for this example. But everything else is changing, right? So that's where the momentum comes in. The nice thing about coordinate descent is it's completely parallelizable, right? You don't need parameter servers or any of that. You could have one of the 20,000 machines looking at, you know, the Miley Cyrus feature, you know, and just like adjusting that one. The way, you know, we were, you know, back in like 2009, we were still suffering greatly. Like deep learning was not popular. It suffered from vanishing gradients and a variety of other issues. And so we got around that by doing a lot of cross products and pairwise, you know, function approximation. So if you have a nonlinear function, you just break it down into small bands and assume each of those bands is linear. If you've ever done Lime or any of these things, it's the same core idea. The models took a really long time to train, and that made development extremely slow. That ended up being a really big problem. So I'll give a brief history. You know, we kind of jumped the gun here, but let's talk about how Sybil started. It started when a bunch of senior folks got together and said we wanted to defeat smartass. So smartass, Google had a product called Smart Ads, and then they decided that name wasn't pretentious enough, so they had to do smartass. That was the second version of it. Smartass was doing hog wild SGD. In hindsight, Smartass actually had the right idea. One challenge was, again, the limitations of the time. You know, they had to use a distributed hash table, and so they're getting collisions all over the place. So imagine, you know, your user ID just happens to collide with Miley Cyrus's user ID, and now you're getting her recommendations. It's just all over the place. We were able to kind of circumvent all of that with the coordinate descent and the other things that I talked about. We also did some really clever regularization. And it showed an improvement, but it wasn't enough to migrate. And I would actually challenge or posture that nothing would have been enough to migrate. There was like hundreds of people. We were in California, they were in New York, they were in Pittsburgh. You know, there's just hundreds of engineers, and like we would have had to just completely blow that system out of the water for them, you know, to get the top-down pressure to switch over. And that was a really important lesson, you know, for me to learn. So we went through this period where basically Fernando and the Google leadership kind of said, look, we have all these high-level people working on this project. It's not doing anything for Google, so you have basically to prove yourself. It's not like half a year. Otherwise, we're just going to find something more productive. That was pretty scary. What we did was we decided, you know, not to keep improving the algorithm, which definitely made Yoram and some people upset, but to really just focus on tooling and to focus on new people. You know, YouTube was just starting to use more machine learning, and we thought if we had really solid tooling, that we could, you know, that would be our edge over you know, other systems in the company. And that worked out really well. I think this is almost a trope at this point, but having, a really solid user experience is extremely important. People value that way more than saying I can get 0.1% more of X. Because ultimately, what they need to do is iterate really quickly, as we showed on the earlier slide. So even if that ML training box is better, if it makes that whole circle slower, then it's not worth it. And the opposite is also true. So we focused on that big picture I showed earlier, and that helped a lot. We could never calibrate these models, and so I'll explain kind of what that means. For example, we would run a replay engine and say we would expect, let's say, the Android Play Store to get X number of clicks tomorrow. And sure enough, it would get X minus T clicks. And T was a really large number. And we could never seem to actually predict the outcome correctly. And what I learned from that experience is, I kind of went into it thinking, well, there's just a bug somewhere. Once we fix the bug, it'll line up. And it turns out, no, like training serving skew is actually just it's part of that flywheel. And it's not going away. It's just constantly something you have to iterate on. I'll talk more about how we can do that. The causes of this skew, like the reason why you can't just take the model you trained and know exactly what's going to happen in the future, is twofold. One, the environment's constantly changing. Imagine you train the model December 20th, and like you launch it on Christmas Eve, right? Oh, it's going to be totally different, right? Unless you have enough data, enough history to factor that in. You've trained it on the past 20 days and you launch it on Christmas Eve or July 4th or something like that, it's not going to match up. That's actually less of a problem. The bigger problem is, it's almost like a Heisenberg principle. Your new model evokes a policy, and that policy changes people's behavior, right? Like if you roll out a new YouTube recommendation algorithm, that's going to change what people see. It's going to permanently change their chemistry. And so that means that you can't account for that because it hasn't happened yet. It's almost impossible, right? And so, again, this is one of these things you have to measure and keep track of, but it's never going to go to zero. Also, there's a ton of business logic in any of these systems. So in the case of, let's say, Facebook, for example, there's some logic that tries to avoid showing multiple posts from the same person, like one after another. And so, that's downstream from the ranking algorithm. And so unless you have that at training time, you're not looking at reality, right? And so you have to try to bring as much of that logic into the training and evaluation system as possible. But again, you never get 100%. There's just so many moving parts, right? So just some examples of things that really shocked us. One, we couldn't get an AA test to succeed. Just some explanation here, some context. Typically with these kind of things, you'll do an A/B test. You'll say, okay, I have my 90% of my audience here. I'll have a holdout set of folks, hopefully from the same distribution. I'll show them the new model, and then I'll measure the difference in performance. I'll say, oh, more people are interacting with the new model. More people are happy with the new model. That's good. Or people are unhappy with the new model. Let's not launch it. We got to a point where we couldn't launch anything. We literally trained exactly the same model on exactly the same data, and we couldn't launch it. And we spent a lot of time trying to figure out what was going on. And what we learned is that people were using the ranking system as a bookmarking system. So they really wanted, they'd search for funny, and then the third entry, that's what they really want. And they just watch a video every day, and it's hilarious. And so when we retrain the model on, even with just a random seed and chaos, right, it won't be the third entry, and then they're disappointed. And so that became a really difficult thing. We had to say, yeah, this model is, doing only slightly worse than the baseline, which means it's amazing, and we should launch it. And that became really hard, right? I still don't have a good answer for that, to be honest. It's a human factor, it's really difficult. Maybe just measuring the discrepancy in an AA test could get us something more principled there. Also, there's just much more straightforward things. The Google Plus team was really in a hurry to roll out this social network. And at one point, I think there were only 6 days of the week, but in the training code, we had figured that there would be 7. And so that was a problem, and said things didn't really line up. And that's a very hard bug to catch, right? Because like one feature is not quite what it should be. And so you end up with probabilities and results that are like slightly off, right? The solutions that we rolled out involve just a lot of statistics and just using statistics to kind of sanity check everything and really treating the data as something that needs to be tested. And so this is becoming pretty mainstream. I still think there's a huge opportunity here for when I look at what's out there in the public domain, but you can measure the distribution of your inputs and see, at serving time, at training time, do these distributions match? For example, this would have easily caught the Google Plus bug because the distribution of Saturdays was 1/7 in training, and at serving, it was 0%. It was never there. So you would have just found that instantly, right? The vast majority of bugs are of that form and can be caught with something like this. But it requires distribution fitting. It requires something like PyOD or some other anomaly detection library, and someone has to kind of connect all those dots. I just don't see a lot of products out there that do that. Yeah, something that's more important on the self-driving space, but you clearly want to record your model inputs and outputs in many different environments and make sure they match. In something like self-driving, you're running on embedded hardware that has a different instruction set, and sometimes there can be bugs that you find there. And the business logic we talked about. So at some point, I got really disaffected with Google Plus. I know I keep railing on Google Plus. I feel like I can beat the dead horse one more time. At one point, they gave this presentation. Larry Page gave this presentation where all of Google, or maybe it was Vic Condotra, where all of Google were like icons, Gmail and research, which is like this atom thing out of the Google colors, and they all like went into the Google Plus box and were a big happy family. And I was like, I said the F word, and I was like, this is dumb, I'm done here. So I went to Apple for a while. I was at Apple for a couple of years. I really enjoyed Apple, I think it's 3 years. The thing I worked on was app recommendations on the device. This was really, really fascinating. I had a great time here. Initially, and since then, they've made a ton of progress here. So we're kind of walking through the beginnings of these projects, right? I mean, they're in a totally different state today. And if you have an iPhone and you use it, this isn't gonna match your experience in 2023, right? We started off with this idea, let's use a logistic regression and rank the apps and say based on your routine, time of day, a whole bunch of other features, let's throw it into some neural network or some logistic regression or some scikit-learn or something, and get a ranking of items. The problem we ran into at the time was that, again, that flywheel that we showed earlier, think about like how much data is involved there. You have your initial data, you have your model, you have your system validation, you're doing A/B testing, you're doing AA testing, all that stuff that I just talked about requires harvesting a ton of data. And and I haven't kept up to date, but at the time, Apple's privacy policy is extremely restrictive. And even for employee devices, we couldn't really see what was going on. We were having a really hard time. I remember at one point, we had a bug where we were showing the worst possible app, like just a 1 - X type thing. And Craig Federighi, kind of sent this nasty email, like, what the heck are these apps? I don't even know I had them on my phone, I'm getting recommended them, it's garbage. And it was like, just a simple bug, but it's like we had hundreds of those, and we just weren't gonna, like Craig Federighi just only has so many emails that he can do in a year before we run out of time. So this was just not practical. What we ended up doing was, again, thinking about that matrix, like where is a place where we can extract a lot of value, and where we get it wrong, it's not that big a deal. And what kind of came to me, I got an Apple CarPlay, which is actually really cool. Apple was willing to pay for people to get CarPlay in their cars, like before you could buy a car with CarPlay. And so they kind of made a mess of my car, but whatever. So I ended up with CarPlay in the car, which is kind of cool. But it was always launching, I don't remember the music app. I don't think Apple Music was even around then, but it was launching some default music app every time. And I was using Spotify, it's super frustrating. And so I said, let's just focus on this. Like, we're always starting to play some audio. So that's the baseline, is random audio from an app. I don't even know why that was chosen. We could do way better than that. And we have a prior that we could be. And the CarPlay folks were super accommodating. So that was good. We had a champion in that team. What we couldn't do is the whole logistic regression neural network thing, because we would run into exactly the same position, right? And so that's where something like Bayes is really nice, right? So we had a pretty simple Bayesian network. We used a Dirichlet prior, and we treated each audio device independently. We calculated sort of a distribution over app launches, and then when we were really confident in one app, then we started recommending it. That worked out really well. And the lesson from that is, deep learning is cool, ChatGPT, really cool. I'm super excited. I usually don't get hyped about things, I'm pretty cynical when it comes to AI stuff, but I'm actually hyped about that. But every model has its place. Like, we're not gonna go to ChatGPT and say, like, hey, train a logistic regression for me, or tell me which app to show, or whatever. Like, different models have their own place in the universe, and that's not gonna go away. There's very few models that are just completely made obsolete. So, there we go. So that gets to the last one. Well, I'll talk a little bit about self-driving, but I haven't made enough mistakes there. So I wanted to mostly talk about Reagent. Reagent was, the premise was, Facebook kind of reached out to me and said, you have all this reinforcement learning background. What if you tried to treat a lot of these problems as kind of robotics problems? What if, this was like pre 2016 election and all that. I mean, things became much more serious. So at the time, we were giving kind of latitude, and we were thinking, let's treat, recommendation systems, let's treat marketing problems, let's treat all of these as kind of like robot control problems, because they kind of are at the end of the day. And that was super, super exciting. I thought this is a really interesting idea. It ties together, two different disciplines in a really beautiful way. I knew it would be really hard to pull off. I was really excited about the idea. And so I went over to Facebook to work on that. And it culminated with this project called Reagent. Initially, I clearly didn't learn the lesson from Sybil, and so we set out to just like complete, destroy the universe and replace it with Reagent. And the way we thought about this was they were really interested at the time in increasing comments. I have to confess, I'm not a heavy Facebook user. At the time, I barely knew what comments were. I had to make an account to go work at Facebook. But I thought, sure, we have the data, we could do this. And we did. We increased the comments by a lot, and all we had to do was just tank every other metric, and the comments went way up. That was bad. We felt like maybe we could put some guardrails around it, boost comments and boost everything else a little bit or something. The real problem, the thing that really froze us in our tracks, was that we were rolling out a model every day, and each one was completely different. The only thing they had in common was they all increased comments. But one model would show like tons of angry things to people, and then the next day, like same code, same everything, sometimes even the same data, is just, random seed, and it would show, a bunch of things, everyone's getting sports all the time, right? And it was just bonkers from one day to the next. So yeah, kind of like Civil, at some point they said, look, we've spent a year on this, we don't really have anything to show for it, let's just take a little bit more time, as much time as you want. They gave me a lot of flexibility, but it was clear that like it felt like it needed to do something. And I was definitely pretty nervous. Yeah, they reduced all the headcount, it was just me, and so I had this decision whether I want to sort of wind this down or try to make it work. The thing I realized was that the newsfeed ranking was this huge Goliath that had just tons and tons of people, tons of interest, and then sometime around here there was the election, right? Then everyone was even more interested in newsfeed ranking, and so it was just really hard to find somebody who says, yes, I want to spend all day on this reinforcement learning project. And there's just so much at stake there too, right? So I said, let me see if I can find teams in the company where they just really are passionate about this new technology, and they have this kind of problem to solve, and they're willing to replace their existing system with this, and they're actually not only willing, but they want to replace it with something else. And so MarTech and marketing ended up just being that place, and they had some very simple models. They were in the process of replacing them anyways. They're super enthusiastic about this, and it ended up working out really well. And we got some headcount, hired the team became an org, and it was an awesome experience. I was there for a total of about 6.5 years, and the whole time on the same project. I think that the other thing is having people who are really excited in the domain is really important. I think we often, especially people in AI research, will think so much about the models and the theory, and we say, oh, this equation is better than this equation, that means it'll eventually work. And we forget this sweat equity, right? If people work really hard on tuning the data, tuning the model, again, going back to that cycle we showed earlier, all those boxes are all working together. And so, if there's a bug in the data, but you're using a random forest, and that random forest is immune to that bug, then it'll probably just slip through. You won't even notice. And if I go and try and replace that with deep reinforcement learning, I'm going to hit that bug. And unless there's a person who's really passionate about making this work and changing all of those boxes, it's just not gonna happen. Right? So we kind of went into this thinking, we'll just take the data from the old model and use a new model, and it would be better. And that did not work at all, right? It's all kind of connected. One thing we did, and I'm sure Reagent is still doing this today, is metrics whack-a-mole. This is a really, really big problem. You either have to put every metric into your model, or it's just going to ignore the ones that you don't put. If you put 2 metrics in, then they're going to compete for attention, right? And so it's not clear until you've done a lot of testing what the marginal value is. So in other words, if you're running, let's say, an ad system, if you could get 10 times as many clicks by sacrificing some tiny epsilon number of conversions, you would do it. It was better for your brand, it keeps people from going ad blind, right, all these things, right? That's a huge marginal trade-off, right? If it's 1-to-1, then probably not, right? Because conversions are much more valuable, right? And so when you make a change in the model, how much are you trading off one for the other is not known in advance. That's a very hard function to learn without trying a whole bunch of models, which takes forever. You can't even try that many models before the environment changes. The way we ended up dealing with this, we knew that metrics and trading off metrics is really hard. We knew that the model kind of has this weird Heisenberg thing where when you change a model, it changes people's behavior. And so we needed something real time, but we couldn't use a really hungry algorithm like deep reinforcement learning in real time. It would just go off the rails, right? We needed something with a low parameter space that could run in real time and modulate the big model that takes the whole data train. And again, we went back to our old friend Bayesian methods. So we had a variety of different things over the years, but all in the realm of like confidence bounds, Bayes ops, these kind of methods to keep the RL system on the rails. Another thing we did is, instead of regularizing to 0, as you typically do, like L2 and these type of these type of things, we regularized to the yesterday's model. So we sort of drove all the weights to yesterday's model, unless they had a real compelling reason to be something different, right? That helped a ton. That was a game changer. And actually, Vivek at Facebook he's now on AR, VR. He's the one who came up with that idea. Yeah, I haven't made enough mistakes. Yeah, we could definitely talk people's ear off about self-driving, but I'm probably maybe over time anyways. Happy to talk about that. The one thing that I would be making a mistake if I didn't tell you all we're hiring. We are hiring. We're looking for AI people, software engineers, people doing cloud, all sorts of different folks. Go to lat.ai and check out the careers page. Pretty exciting. I think I wish I could show you all some pictures of some really exciting Ford cars, but they won't let me do that yet. But it is awesome, and it's something real. Like you could drive this in real life, which is pretty cool. So if you're interested in that, you can also just talk to me afterwards. How am I doing on time?
Yeah, you can take some questions.
Okay, yeah, there's some takeaways. I'll share the slides later. I don't know if I have anything that I didn't really talk about. That's just a recap. These are some companies you could start today, probably make some good money. I guess the hard part is getting your whale customer, right? But these are things that I've seen over and over again that don't have, there isn't really a product off the shelf that does that. And yeah, I'll open it up for questions. Yeah.
I'm just curious, your general thoughts on the large language models and how that's going to change things.
Yeah, it's a good question. I think everybody learned something which, I think some research folks have known for a while, which is that embeddings are extraordinarily powerful, right? You have there's this theory that says once you get to like 1,000, 2,000 dimensions, you can actually hold like billions of unique concepts in 2,000 numbers, as long as you're willing to tolerate some flexibility there. That's how like the embedding can be so powerful, right? And so I think that you'll see a lot more of that, where I'm waiting for sort of the ChatGPT of robotics, where when you imagine you buy a robot arm, and what comes with the robot arm is a GitHub repository that has like a 40 gigabyte machine learning model, where they've had that robot arm do everything, and they have a forward kinematic model that's all fully differentiable, right? So like I think that's really the future. So I think the chat stuff is cool, the image stuff is cool. I think it's like a beautiful art tool. I think people will try to do some tricks to like hook it into databases and things like that, and I think that will work well. So I believe in the idea as it stands, but I think the real interesting thing is going to be taking that concept and applying it to a whole bunch of other disciplines.
I mean, we've seen that it's simulated robotics, right? Though, like even like last year at CDPR, they were kind of showing that if you basically just take an internet trained large language model and hook it up to these simulated robotics, like real world learning experience, like it augments the performance. I just wonder if like in the case of like a real robotic arm, you're dealing with so much like complexity there. I wonder how like soon we'll actually see that.
Yeah, it's a good question. I think it'll be relatively soon. I think I mean, the transfer learning to large language model is clever. I haven't seen that paper, but you could imagine just having a simulator of the arm and just in the cloud. The simulator has to be super accurate and everything, but in the cloud, just blasting through that and getting some really powerful forward model. There's this paper that I loved, this Mu0 paper, where they did a forward model and a policy optimization all in one end-to-end system. So it's like basically it learns the concept of chess and the moves and what the moves do to the board, and how to play chess, like all in one neural network. So I think that's some stuff we're really excited about. Yep.
So as a machine learning scientist, you probably spent a lot of time babysitting and debugging models, monitoring them. I was wondering, looking back over all your experience, where you spent the most time in terms of techniques to do that, in terms of like looking at logs or methodical experimentation, and what you think was the technique you went to most. And then looking forward, how would you like to spend your time, and what sort of tools do you want to do other things besides babysit and monitor these models?
Yeah, it's a great question. I think that's a really good question. You know, now that I've started managing researchers, you know, it's incredibly stressful and frustrating, you know, tuning these models, because, you know, like imagine, you know, you try to tune this model, you're trying all these different hyperparameters, you're trying to mess with this data, you can't get it done in time, you get a bad rating, and you feel like it's not your fault. You feel like, oh, I got this PhD just like I press up, enter, right, over and over again. Yeah, I think, you know, that is tough. You know, I think but on the flip side, it is kind of like an endorphin rush too, and you do kind of, you know, make that big leap forward. I think that I would love if, you know, especially now I work on a model, and then, or I'll consult with a model, and then we'll move on to something else. And that model every day is still updating. And we had an issue at Argo where there was a model that we didn't have a recurring training for it. It was lane change detection, detecting if someone's going to change lanes. And we realized, oh, this model's a year old. And actually what happened, the real story here is the guy who made that model quit, and we all panicked. And so we said, okay, let's retrain this model. And we retrained the model, and it was so much better. And we didn't even do anything. It's just we had more data, and, you know, all other parts of the system got better. And we were kicking ourselves, like, oh, we should have rolled out this better model, like literally zero effort, and we got a better model. So I would love if, you know, we have to spend the time to do it once, but then if it just monitored itself after that, you know, and if I got an email, it could look like Clippy, I won't get upset, right? But if Clippy, you know, pings me on Slack and says, hey, today's model, you know, this feature is off, or today's model, the loss is like way higher than it was yesterday. That would be awesome. I mean, it would save us so much time and effort.
I have a comment on the monitoring piece. I feel like as model development gets more into data-centric, monitoring is getting more into data-centric as well. Because even though you can have very objective monitoring statistics, like you can measure your PSI, you can measure your data distribution, but still there's always a subjective way to how to interpret those statistics. Say, if you want to use this PS test or the other statistics, like their result could be interpreted totally different way. So I've seen like more common in the industry now is people just make it more data centric, get a bunch of statistics all at the same time, and then log everything just like code and software systems, and in the end we can like always refer back, have that reference data sheet to see like what should we monitor as we back test the system again and again.
Yeah, that makes sense. There's a bunch of amazing tools out there at a low level, like to do distribution fitting. PyOD is one I keep bringing up for anomaly detection, but it's just, you know, people haven't quite kind of built them up. And I think one of the reasons why you don't see a lot of this productionized is it's hard to build a generic thing at the moment. Similar to how like Sybil at the time was really hard, and now if you want to do logistic regression, you just open up PyTorch. They probably teach it in high school, right? And so like I think that is now on the vanguard, and that is now hard, but eventually it'll be used.
Are you leaning towards the prescriptive or opinionated way of building ML pipelines or flexibility? Because nowadays there are a lot of ML ops tools out there, but some are very opinionated, kind of
Yeah.
wants to guardrail and drive data scientists or machine learning engineers how to build their pipeline. Some are more flexible, you just build your own modules and then connect it together. There are like pros and cons of different approaches. Want to hear your opinion on that?
Yeah, there's this awesome website, mymlops.com, and it lets you like assemble, your ideal, tool bench, right? What I've found is that a lot of these tools, you're right, they're opinionated, and they try to do too much. Like, I'll give you I don't want to throw anyone under the bus, but there's like a tool where they did one thing really well, but then to do it, you had to use their workflow engine, and we were already using Kubeflow. And so we had an engineer try their workflow engine, and it wasn't good. And so then we kind of wholesale had to reject that vendor, right? So yeah, I understand folks saying, like, someone trying to be kingmaker and say, like, I want to be able to do everything, but what we found is it's best if there's, like, as you said, like a consortium, a soup of tools, and none of them are so opinionated that they strangle any of the others, right? So currently, at Latitude, we're using weights and biases for experiment tracking, but then we're using Dagster for workflows. We're not using the weights and biases, launcher. And it goes on, but it's a bunch of, we're using LakeFS for storing the data. So there's a whole bunch of little tools that we're assembling to make our whole system. Yeah. I think you had a question, yeah.
Yeah, you mentioned for one of the last projects you worked on regularizing the previous day's weights.
Yep.
But then like you kind of, you were like, if it does better though according to some criteria, then we're gonna take the new weights. I would love if you could dig in more about like what that actually looks like.
Yeah, it's a good question. So it's not necessarily better. It's more like, so with regularization in general, right? The weights are being driven to zero by the regularization term, but not all the weights are zero because that regularization term is overcome by the gradient. The gradient's driving this weight to 3, and that ends up being important enough, the regularization. And you can tune these, right? The same kind of idea, but instead, it's trying to drive the weight to its initial value, which might not be 0.
Okay, you're just setting the mean to be like.
Exactly, yeah. So it's all at that point based on the loss for that particular mini batch. So it's not necessarily that we're going to take the good changes. It's more just it's looking at the magnitude of the gradient. Yeah. Sure.
If you were to assemble like a strike team for like a new ML project that is on the level of some of the ones that you tackle, like what skill sets are you looking for? Like, do you need a DevOps person? Do you need a software engineer? And then how big would that team?
Yeah, that's a phenomenal question. It's a really, really good question. Because we recently had to kind of go through this. TLDR, when we got acquired by Ford, not everyone wanted to go to Ford, and we didn't want to take people who are unwilling and all of that. So we basically gave people the option, like, company's getting acquired, you either go to the new company or we'll do like a severance thing, right? And so some people really wanted to be at a startup, and they wanted to do like the startup equity thing. So I'll give you kind of way more information than you probably want to hear, but we get Ford, stock, which I think is fine, but some people might want to get, options in a small company and all that. And so at the end, we had pretty good retention. I think it was like 90% of the people went to Ford, but we had to look at that 10% and see, what gaps do we have, right? I think that it's really hard to hire, people who have that sort of statistical mindset. I think that's a really difficult role to find. And you kind of have to ask yourself, like, let's say somebody's a math major and they've never written code before, then, do you cross-train? Do you kind of wait for somebody who has kind of like, good coding and the strong math skills? Like, these are really kind of difficult questions, and they change organizations. Like, for example, Facebook, when I joined, didn't have research scientists. It wasn't a job. And what would happen is, amazing research scientists would come in, interview, fail the coding interview, they can't like invert a binary tree, and we'd have to like tell them to go home, right? And we got kind of sick of that, right? And so we created the research scientist role. So, you know, it's very kind of difficult where to strike that balance. You definitely would want somebody who can, you know, manage all the statistics behind, you know, this whole process, right? You need to run at scale. You know, I didn't cover this slide, but there's a huge gap between if a model takes a week to train, a day to train, or an hour to train. You're going to get 3 completely different workflows. Like imagine if ChatGPT took a day. It would be completely different. It would be a totally different product, right? So, you know, you need people who are going to do the work of like getting, like in our case, getting the images and the video through the pipeline fast. You know, we had models that were taking, you know, weeks to train and now take an hour, just because like there's that much gain from getting somebody who really understands how to move that data around quickly. And then you need solid data engineers, you know, people who can do ETL, who are, you know, good at SQL, good at coming up with dashboards and using BI tools, right? So yeah, I would say, you know, solid, and in our case, you need embedded people. You know, that you might not need that depending on what you're doing. But I would say, you know, solid cloud platform, data engineers, ML engineers, and people who can do the low-level moving bits quickly, and then, you know, research and data scientists. All right, and I'll be here. I think we're all going to get a drink afterwards. I don't know what's happening, but I'll be here for a while afterwards. Thanks everyone for your time.
Thank you. I think we can take a 3 to 5 minutes break before our next speaker starts the next talk. During the break, you can get your connection ready. Yeah, please take the advantage to network and meet some new people.
Thanks for the talk, Jason.
Yeah, thank you. Thanks for the question.
So I used to run arm research, and so yeah, we had this interesting thing between engineering and research and hiring. I remember presenting about this is why research exists, this is why the research engineer should be in research and not engineering.
Right.
You know, just the whole, you know, what we value and how we develop. So something similar here.
Oh, in Austin, we have 12 of them. Most of them are in Pittsburgh. And you would expect like a lot of the onboard people are in Pittsburgh. And then a lot of the cloud ML stuff is California. Yeah, we're at 12, which is a pretty good number. Once we get to around 20 or so, then we'll get a number.
Are you guys all virtual?
Yeah, we're all
I really enjoy I guess the details and the stories. I had to work with some YouTubers and video coding and all that. They'd always complain about the algorithm, you know, how it works. And I'm like, well, they probably can't just explain it. Like, I was on the top and then went away.
Especially like now on YouTube as well, but I remember basically every time we rolled out a model, we just some number of stuff every single time.
Yeah.
And I just can't imagine like you know, Google tech support.
Yeah.
It'd be a wild place. It's like, well, you know, you're on this side of the aisle. Like,
And the other side, they'd be like, I changed my logo. Listen, I'm like, I don't think it's that. I think it's probably something else. But how do I figure that out?
or the biggest one is Facebook's listening to my phone all the time.
Okay.
Even my parents. Yeah, it's like, oh, you know, I talked about tomatoes, and I got
My theory on that, by the way,
oh, which is
that humans have a similar generative distribution to whatever it's doing, so you're going to end up talking about what you've used enough times prior that you're going to now bring it up, and coincidentally the model is converging on that same conclusion very closely to the same time, which then makes it look almost at the same time to you.
So why there's only 26 types of people or something like that?
Oh yeah, 50 pages of instructions, right?
You know,
32K context in our case.
it's like that. I was like, how did it know? It's just like because everyone else is looking at that too.
I got a bunch of
people don't realize this. Like, if you talk about tomatoes and your friend
Did I steal your chair here?
tomato ad, that's gonna make you start getting tomatoes. You'll see this occasionally where you might get an ad for a product that's lifelike.
So I was curious in the marketing stuff, so what was that like optimizing? Because you're an ad company, other companies are trying to buy marketing stuff, so are you trying to sell it? Or what was the problem?
So there's a handful of things. So one is, we had coupons, and so we could basically figure out, if I give this person a coupon, what is the likelihood that they'll either create an account or that they'll do some derivative spend with the coupon? And then we also did some re-engagement marketing. So, if somebody is not advertising, but they were in the past, like what's the right time to come back to them and say, hey, why don't you try it again?
Yeah, I'm personally really interested. I do a lot of business ventures, so the question between just normal business, manager stuff versus what we should be doing in our model, what really we need. A lot of this is just when you it comes up just as like copywriting and whatever people are talking about. I heard that one.
Yeah, no, well, essentially,
Some people jump into some questions here.
I think they're gonna start, I just want to come by, so I sometimes prefer to do that, and always I do. Good job, that was nice.
Oh, thanks. Yeah.
I didn't know you worked at Apple and Google.
Yeah, I gotta get everywhere.
Hi everyone.
So are you planning to set it
If
off
anyone
here in
parked
Austin?
in the Capital
Yeah, I'll
Factory
be here for
garage,
a
I have some parking validations for you. So if anyone needs one, come see me. Thank you.
Question, so you had identified kind of having more than one objective, right, where it's just like, well, you got all the comments in the world, it's like the paperclip question, right, where it's, you tell AI to make pictures, and so I was just wondering, like, how do you view that problem with reference to the alignment problem? Because basically the alignment problem is an objective that's a series of sub-objectives that aren't defined, so like, I know there's like, multi-arm bandage scenarios, like all those kind of thought processes, but like, I guess with your staged experience coming from seeing like logistic regression and like into civil, into how would you think about the generalization of the two objectives?
Yeah, I mean, both objectives are really tough. I think that the challenge is like the economic like the trade-off. Really good papers on this.
Do you have a Twitter?
Oh yeah, you just type in Twitter.
Trying to figure out like how to jumpstart
Yeah, that's right. That might be a lot.
Yeah, I used to just write it down, but I realized how many times I just messed up the spelling or something. And I'm like, this person doesn't read this. But I just do to follow and send a follow message right away about the question.
I like, I have a high.
smaller model.
I guess like the follow-up then would be, but that's assuming that it's, you get to an agreement on the check, right? But let's assume there's like a global layer, right? Like an Ethereum style, like, supercomputer piggyback, like, not in the like, you can't agree on objectives. How do you optimize for objectives that not everyone can agree on without just doing the tyranny of the majority, you know? And just kind of like mass spam produce children, like,
Yeah, you will start in 1 minute. You will start in 1
I guess you could think of it maybe even as a neutrality too, right? Just like the convenience of how many people, the safety of how many people, the legality of how many people, how the importance of the weight of each of these things, and the consequences versus just taking one step out. Because obviously you can't go a million steps out, like, no, I cut this guy off and go kill somebody. I can't do that, but like, you know, one step out, I think
right around 200. Yeah, thanks to Rose and continue to grow. Yeah, no, that's cool. Yeah, I joined in December, so I'm on like over the past, I want to say, year, but I think we're gonna stick around
well, you know, either sorry or thank you for your welcome, I guess. But that was my forward. I was the researcher, so there's absurd amounts of heuristics for the model. Yeah, we should see what.
Okay, it's 6:46. Let's start our second talk. And I think many of you showed interest in some monitoring of machine learning models. And I think weights and the bias. We'll provide some helpful information about that. Yeah, you'll let the speakers tell you more about what they do.
Cool. Well, hey everyone, my name is Ken Lee. I'm a machine learning engineer at Weights and Biases. I've been here for about a year. Before I was at Data Robot. And I've lived in Austin for like 12 years, went to UT, background in machine learning. But yeah, pleasure to speak with you all today. Claire, you want to?
Hey everyone, I'm Claire. I am also a machine learning engineer at Weights and Biases, and before that in AutoML, background in NLP and working in some cool space in machine learning ops and monitoring in that space. So excited to be here. Thanks for having us.
Alrighty. Well, yeah. So today we're gonna talk about principled ML workflows. I think if you've worked in this space for a while, the tooling has been very lacking. So it's kind of been a wild west in terms of managing all of the things Jason talked about in that loop. It's just keeping track of all of that information, whether that's your data sets, your metrics, your visualizations. For a long time, it's been chaos. And Weights and Biases was very much built to address a lot of that chaos and to help wrangle a lot of it. And so if you are a data scientist or machine learning engineer, at some point you've probably run an experiment and you've recorded your metrics in like Notepad or Excel or something like that. And then you might move on to a spreadsheet in the cloud, make things a little bit easier. And then you might adopt something like TensorBoard. And that's all well and good for a little bit if you're working individually as a practitioner. But then a teammate comes along and you want to work on a project together. Well, you have to start sharing results with each other. And so you have to sync your TensorBoards with their TensorBoards, or you have to share your Google Drive. And this becomes even a bigger problem if you have a large team and you're tackling a complex project.
And then quickly this devolves, you have notebooks that you're passing around, you're emailing people, you have Confluence, PowerPoint, Teams, Slack, and it quickly degrades. And you're putting a lot of money and effort into these experiments. Like, if you're training these LLMs or large computer vision models, you're throwing a lot of GPU capital at this. And if you're just gonna lose those metrics in someone's Gmail, like you're losing that money essentially. So what are the principles of an ideal ML workflow? ML development is very iterative, very experimental, and you want to be able to rapidly iterate as much as possible, while at the same time keeping track of everything and making sure whatever you do is reproducible and auditable. I, in particular, work with a lot of our healthcare and biotech customers, and a lot of the algorithms that they develop qualify as medical devices, and they have to put all of that through FDA approval. And that requires knowing the data set that the model was trained on, all of the metrics, the snapshots, all of that needs to be in a place that you can show the FDA. And then just facilitating collaboration is really important. Working on some of these large projects, like the GPT projects, like a lot of the healthcare biotech projects, you're on a team with like 20 to 100 ML engineers. They need to be able to see everyone's work and hand off different assets to each other, whether that's handing off a model to a DevOps engineer to deploy that model, or if you're building a report to share with a clinician or a subject matter expert. How many of you in this room have like experienced that like workflow that I just showed at some point or another? Yeah. Actually, just curious, who all in the room uses weights and biases today? Okay, I got a hand. Cool.
I use MLflow too as well.
Yeah, we can get into some comparisons if you'd like. So some of the core modules in weights and biases help address this development workflow that I just talked about. So one is just experiment tracking. When you train a model or you fine tune a model, you need to be able to keep track of all your metrics, whether that's like your loss curves, things like precision, recall, accuracy, the usual suspects. And then we have a lot of like integrations with pretty much all of the popular ML libraries out there. So if you're using like PyTorch Lightning today, we have integration with them, Hugging Face, and then pretty much any library out there has either built-in integration or we built an integration. And I can talk about what that looks like. Using weights and biases is very low friction. We don't want to enforce a pattern that's opinionated, as someone mentioned earlier. Like, we want you to use whatever you're using today, but add a lightweight layer of API code to log the context of what's happening. And then we have artifacts and model registry. So ML development is very artifact heavy. You're passing around data sets and model checkpoints around all the time. If you're training a large model, you have to checkpoint the model throughout training. And and that's especially important if your instance crashes and you have to resume training from a certain point in time. So storing your checkpoints in a central place can be very helpful for that. And then we have reports for documentation. So I think we've all probably built a PowerPoint where we've copied and pasted a chart or two into the PowerPoint and then shared it. Reports helps make this documentation process very easy. So we can transition directly from what we've logged to a document that we can share with others. And if we have time, we'll get into sweeps and launch. These are kind of newer modules, but these are for launching experiments into compute environments of your choice. But I think by and large, most of our customers use weights and biases as their ML system of record. And so I was going to jump into a brief demo. But before I do that, any questions or commentary on trials and tribulations in ML development?
I have a false impression about the relationship between weights and bias and Google. Are you guys sponsored by Google?
No. We do have teams in Google using us, but
Okay.
they're not investors of us or anything.
It's probably Steve. I'm sorry.
But yeah, feel free to interrupt or add any testimony. But what you're looking at now is like the weights and biases dashboard. So this is where you can see all the experiments related to a given project, all the metrics that those experiments are recording. And for any particular experiment, I can click into it and see not only the metrics that someone logged explicitly, but a bunch of meta information that can be really helpful if you're looking back at a project that maybe you did like months ago and you're trying to figure out like, all right, what did this person do? What Python version were they using? All right, they're using some GPUs here. Here are their config, like hyperparameters. Let me look at their notebook. So notebooks are like oftentimes just spaghetti code because you're executing stuff out of order, and then like they got certain results, but they executed the code in this weird order. So like we'll record the session history of the notebook so you can get exactly the execution order that that person did to get to where they were. We'll also track like system utilization, so GPU and CPU, make sure you're utilizing the GPU effectively. Basically, weights and biases extracts everything, the entire execution context of your code. So you can take this and reproduce it exactly. And our launch module actually does that exactly. So it will take all this metadata and rematerialize this as a run you can re-execute anywhere. It'll take care of the containerization of it and all that good stuff. And so this workspace is very flexible, right? Like you can come, we can do some meta-analysis. Maybe we want to see like the different hyperparameters and how our experiments vary across that space. And then a really useful functionality is not just logging like aggregate metrics, but logging individual predictions. Very useful for like computer vision NLP, where beyond just seeing your loss curve go down to the right, you need to see how the model is performing on specific examples. And like where the model is struggling, do I need to relabel my data, do I need to extract or obtain new data in different regions of my distribution? And so you can log basically data frames that embed rich media. So for this computer vision task, I've logged some validation data sets. And then here we can easily compare with the different colors, the different runs that I've logged to this data set. So this is an easy way to do like model debugging and comparison. And then, so this workspace is where project managers will come in, they'll see what their ML engineers are doing, where the researchers themselves can just keep track of all their work. But it's just a nice central place where everyone can come in and see what is happening for a project. A general next step in the development cycle, one is documentation. Really important in this space. And what would typically happen, as I described before, is you might take some of these charts, copy and paste them into a PowerPoint deck, and then send it off. Well, Weights and Biases created this module called Reports that lets you take whatever you logged in the experimental system of record and create a living document where you can embed any chart, metric, table directly into a report that you can then kind of edit like Notion, where you can surround like your charts and metrics with table of contents, code blocks, LaTeX, and you can build this really nice technical documentation or even like dashboards to share with whoever, even people not using weights and biases. OpenAI actually uses reports. In their office, they have a giant screen that's on all the time, and it shows a weights and biases report. And when they train the GPT models, they just have a single global dashboard of like how everything's going. And so everything is linked to everything we've logged before in the reports. So I can come and look at my runs, tag my runs, and then click into the runs like I did before. So I don't have to copy and paste and keep track of things kind of in an idiosyncratic way. So you can wind up with really nice reports that go through, the detail of a model, and then alongside that, the actual results of that implementation. So we have banks using this for MRM, like I said, FDA approval for the biotech healthcare persona, And then in high tech, people use these just as technical documentation. And in of course, like all the NLP companies, LLM companies out there will also use weights and biases to track predictions or prompts as they're engineering these models as well.
For these, Ken, actually, can you show the Weave editor real quick? Just since Jason had mentioned, the sweat equity that goes into this, just coming from NLP. I mean, I think this could apply to a lot of things in machine learning space, but text is so insanely subjective and messy to deal with, and there's so many different ways of saying things. So, like in the past, like I've done a lot of work in pandas and things like that, but this table is really nice because we have a back-end expression editor behind it that you can use to interrogate the table, search for terms, search for fields containing things. Can you mind opening up the editor itself? Did you do that already? No, over on the left, just the filter guy. Yeah. So like, if you want to look for, build out kind of intensive expressions to search for certain things in text or compare columns or things like that, just some of the sort of unglamorous work that goes into, for example, text analysis, and then figuring out, if you were thinking about like prompt engineering examples, where things are going awry with very specific examples when you need to get to that level versus looking at a large aggregate chart or maybe just a small sample of things. Tables can be a very flexible way of either looking at specific subsets of data, training runs, after you've done particular pre-processing steps, things like that. So, I don't know, it seems self-evident, but I think, working with text can be kind of a huge headache when you're at the point where you either need to check data quality or look at individual results at training or inference. So, just wanted to throw in that side commentary. Any questions on these so far? Reports or setting these up? It's kind of yeah, go ahead.
You said a back-end expression, what was the phrase you used to describe
It's called
that?
Weave. It's it's weights and biases in specific, but it's how these tables are put together, and it's kind of an underpinning of the platform itself in terms of tables.
Okay, and what was the topic that you used to describe it? It was a back-end language of something?
Expression editor, yeah.
Okay. Thank you.
Yeah, of course. Yeah, go ahead.
One user journey, if you're using like dedicated hardware, you might want to get like a sense of like the timeline view of like operations to get like a sense of like how long one step takes. I'm wondering if weights and biases has any way to like showcase that.
Like profilers,
yeah.
So we have integrations with some profilers, like PyTorch profiler. You can log results of Onyx profiler pretty easily. We don't do anything explicitly. Like a lot of this type of things, we defer to whatever library or tool does that already. But that is something like, we run into this all the time with it in the AV space, because they have to profile the models on the hardware before it moves on. And we'll help keep track of the models as they move through different quantization steps or serialization steps. But yeah, that's a good point.
Is auto-logging, sorry, go ahead, I think you haven't finished yet.
No, go ahead.
Okay, is auto-logging available, or user need to write the API explicitly to create the logs?
Yeah, so you will have to use our API. Now, a lot of libraries, like I said, PyTorch Lightning and some others, have a very easy callback system where you're like, passing a 1DB logger or argument. Keras is similar. And it will then log things automatically, like your model checkpoints. I did tests recently though. So ChatGPT knows weights and biases and is really good at integrating code. So if you need a quick integration, and you're willing to share your code with ChatGPT, that's a good option.
Do you have a plugin?
We're working on it actually. We have a 1DB bot.
What's the overhead?
Overhead for adding the code?
For adding the monitor?
It's really just a few lines of code.
I mean in performance.
Oh, there's actually no performance hit, or it's minimal, so because we spawn a separate process that is logging the assets, the weights and biases from the training process. MLflow actually does not do that from our understanding.
The system metrics to answer with auto logging is auto logged, what Ken was showing on the prior page. But like
Yeah.
performance metrics or any of the artifacts or things like that, you do through the SDK.
Yeah, and I wasn't really planning on showing code, but it's gonna work something really simple like wanddb.init. You pass your project entity, whatever metadata you want to pass to organize the run, like config parameters, and then you wanddb.log to log pretty much anything from scalar metrics to images to tables.
How does the permission provisioning works in a workspace? Can you specify like which team member have access to which assets and who does not?
Today everything is done at the team level, so permissions are dictated by the teams you belong to. Pretty soon though we're going to release granular role-based access control at the user level.
And what kind of permission granting do you have? Like what levels of permissions or what different levels of permissions usually have? Like say for example, sometimes most people have like can view and some people have can manage or can edit. Like how are those permissions segmented?
Yeah, today we have view only and then regular users and then admin users. Admin users I think can like do things like deletions of projects.
Yeah, currently for like a larger organization, people will segment by team, and then people within teams can all send runs to a project, view those, create extra columns and tables, you know, those kind of things. But yeah, that's the current way that people divide it if there are things that maybe wouldn't be seen. And then share if there are like visualizations or tables like that, those get moved into a report. A report could be made view only if you have like stakeholders or project managers, someone like that who doesn't need to be actually in the workspace.
Thanks.
So another thing I wanted to talk about is kind of the other piece of the system of record. Beyond experiments and metrics and visualizations is artifacts. So any serialized data that you need to track in ML development is what would be considered an artifact. This could be a data set, a model checkpoint, it could be evaluation results. All of these things are important to track as you're like relabeling data, acquiring new data, and then of course generating your model checkpoints. And so what you're looking at here is a DAG view of all the runs we've logged in weights and biases. So a run is just something that we've, or either an experiment or Python script we've annotated with wanddb.init. And then in between are the artifacts that they produce and consume. So you've got data sets, models, but everything is versioned through checksumming of the underlying assets. So I can come in, click on a particular run, and then understand the exact versions of a data set that it utilized, along with the model that it produced. And everything is accessed through a simple naming and aliasing system. So kind of like Docker containers where you have names and tags. Here, if I want to pull down a data asset or a model checkpoint, I just refer to it with its name and alias. And I can add whatever aliases I want. But this serves as like a nice abstraction layer on top of serialized data, whether that data is living in object stores like S3 or GCS, or if it's locally on an on-prem shared file system. But you can hand these things off now really easily. If you tell someone I trained this model on this data set, you tell them the name and alias, they can go pull it down, inspect it, and whatever else. Any questions? And so on top of artifacts, we also have like a model registry, which is just a central place to like bookmark checkpoints that matter. And so here you can kind of build rich model cards around your models. describe what they are, how to use them. And this just makes the handoff between researchers and like DevOps or software engineers that are deploying these models a lot easier. I know I've thrown Jupyter notebooks over the fence plenty of times, or I've received Jupyter notebooks that I have to go and deploy, and that's just a giant pain. With weights and biases, you have like access to not only the checkpoint, but how the checkpoint was generated. You can go inspect how that person created that model, and that just makes it a whole lot easier when it comes to using it.
So if user were to use the model artifacts from the model registry for inference, do they need to build their own customized inference pipeline, or there's a standardized API to load all models from different platforms?
Mm-hmm.
Say if there's an sklearn model or a TensorFlow model, do they load it the same way for inference, or it depends on, like, it's user's responsibility to build a corresponding pipeline?
So it would be up to the user to take care of like loading the model into memory for serving it. We would just take care of versioning the serialized files. This is one way in which we differ from MLflow. MLflow has this way of like loading the model and saving it. We decided to become unopinionated on that because we have a lot of customers that build their own custom like frameworks. Although we are, with Weave, building out a way for you to customize how serialization and deserialization occurs, and have weights and biases take care of that.
Gotcha. Thanks.
Cool. Well, that pretty much covers like the overall brief demo of what weights and biases is. It's a system of record for machine learning. If you are building machine learning models and you aren't using it today, you can try it out for free as personal use. And like if you want to adopt it as a team, you know, feel free to contact us. I'll show contact information. But yeah, working in the ML space now for like 8 years or so myself, I've found this tool to be like game changing for a lot of teams. And then on top of that, next week we're doing a weights and biases ML happy hour. It's going to be free drinks, free food, a lot of LLM gossip, because that's all we do nowadays. So yeah, register here, and yeah, we'd love to see you there.
Any other questions?
I guess I'm curious on the LLM side. So I see this for training. That seems real straightforward. But if you're doing prompt engineering and using LangChain or something to chain a bunch of models together and mixing out models and dealing with that, is that what you use Weave for with the tags, or how would I manage?
So I can't speak about this today. We're making an announcement tomorrow. So
Okay.
on LinkedIn, follow weights and biases, because
Okay.
there's some exciting stuff happening with LangChain and prompt engineering.
Okay, because a day is like a month.
Yeah.
Okay.
But yeah, we're definitely on that, and there will be new workflows for that.
Okay.
How do you collect customer feedback and get those arguments when, everyone's a machine learning scientist now, things like that?
Yeah, that's a good question. I mean, if you were to use weights and biases in enterprise capacity, we have a Slack channel with all of our customers. So it's a direct line of feedback. They'll just like say, hey, I need this to work better, or I would like this to be a new feature. That automatically triggers a ticket, and then so we're very engaged with customers.
I think the size that we're at too, we have about 200 employees now. We're still able to spread that out across our customers pretty well. We have a lot of academic users who are very vocal. We have a growth team that monitors what people are saying out and about in the world that we try to pay really close attention to. It's hard, but some of the typical channels.
I do want to thank you guys for sponsoring a lot of stuff in the community. It's really good to see.
Yeah.
Thanks for your time.
Thank you, everyone. So I will do the spin wheel and choose 2 winners to send the free book. If you want to if you want to enter the raffle and have not reply the LinkedIn post or use the hashtag, please do it now. And I will start the wheel of the wheel. Click to spin now. Okay. I don't have many participants. I will click to spin and see who will get our first one. First one is from Twitter, Landa the Free.
Hooray!
Yeah, so this is the book for you.
Thank you very much.
You're welcome.
My dream come true.
And
A t-shirt.
let's do another one. Next one is from Twitter too. See the contrast. Oh yeah. Thank you for participating. Yeah. So I hope you enjoyed our today's event, and feel free to stay here for a little bit longer and ask speakers questions if you have any questions you want to ask, or network with your neighbors or any participants here. I hope to see you in our future events as well. Thank you so much
And it's like,
That's awesome.
but yeah, it worked out well. I'm audited for about subscribers. So yeah, I'm excited as for I actually really like the show so much better. It's really more like this. We really give you advice for, might not cost a lot or
Keeping up and happy to see you again.
just like with going it's always a tough like someone who is a software developer orders this person will know like a fundamental but if you can land the skill that the person is actually like there were people that did research and they were really good so like in your case, you got one so like
Yeah, that's a 5-question survey.
It's hard to say. I think that, sort of optimizing for like the demand of the job, find out what you're interested in. Let that really guide you. Like, if machine learning is like your nature, how big you can do it. Regardless, even if there was one position, they would have if you don't want to do it, don't do it just because there's a lot of size. What's your placement?
Right.
Yeah, but trying to get some hard data. I mean, I personally would I'm not against doctors.
Yeah, it is, but it's for Western, I would say. Yeah.
Broadly speaking, So I'm gonna wait. And so I don't know if we're going to hit the 2025, that one apparently has a lot of benefits. I don't know about I want to go.
Well, no, I didn't think it was
Hey, Jason.
Jason, Eric, really nice talk. I really enjoyed that one. Thanks for coming down.
Yeah, this is great.
When you were named first place
Oh, yeah.
Was that here?
Yes. Oh, I'm Matt, by the way. Hey, Jason. Jason, can we chat this all about
What about latitude AI? Do you guys have office here too?
So not yet. So Argo, the way that the whole acquisition worked out, like the office kind of stayed with the old company, and so we're thinking about getting another WeWork. We had a WeWork, so we were just thinking about this. So we're thinking about getting another WeWork.
Nice meeting you again. I gotta go. See you next time. Keep in touch.
I was gonna say, I've just been hearing more about like the scale of training challenges that you guys are doing. I spent like 2 years in flight data and training flight data. Oh, TikToks. It was like a senior research engineer, so like self-supervised video understanding. So like we were training up Dino on like our petabytes of video data. So I'm like always curious, like I've never applied that in when I was in the Bay Area. Yeah, so I asked like, it was like me and like 100 research scientists. But I'd be really curious to hear like what kind of video challenges you get from self-driving. Also probably. Yeah, there's a lot of great stuff. There's I mean, LiDAR things are a lot easier. There's a lot of like, yes, that is really difficult. With LiDAR, at least you can say, like, okay, it's roughly this shape, and it's like moving. So it's like, you use a movement test, like perception stack. Yeah, no, the thing is, Tesla's a problem because so like now they make LiDAR very they make imaging radar. Yeah, there's like and so they get it.
They do have another hardware war coming out. I think some of the magazines are taking their 45 years an hour.
Yeah, I mean, so cheap. I mean, LiDAR used to cost a ton of money. 30K, 100K. You can get them for $300. They're really nice. They're not even anywhere.
Because the cameras have trouble with weather too.
But then, like, it's okay.
Have you guys ever hired a hospital? Oh, we are. Oh, yeah, Lab.ai. For years. Yeah, my work is hired. Yeah.
But then I guess we got the point that, like, I can check it out.
At the same time, thanks for doing this. Here's all the experience. Really helpful. Yeah,
but in a way that is like easy. They still press the button.
So I actually am a founder. I live out of state. I study at Stanford. just closed our Series A. Would love to connect. We have so I'm kind of just out here scouting as I was right here with 2018, like going to Meetup, trying to meet people, like going back to California. And you'll love it here. I have family here, so it's kind of biased. Even if this place wasn't good, I would go extended family. But I feel like I can distance myself from that. Saves like just clarifying nowadays. I sent you a LinkedIn. I saw you connected. Cool. I'd love to connect with you and grab a coffee sometime. Just kind of hear more about the scene. My family's all. I'm already away from my family, but my family's from Michigan. So. But yeah, we're an AI framework, so we're doing a lot of really cool stuff in narrow models, so very narrow, high performance models that kind of tether. A lot of work in vision right now, so we're helping work with like a couple Fortune 100 airlines, and then do a lot with like SpaceX. Yeah, I'd love to chat. Super nice to meet you.
So, like, what did you think about one question I had was, I wanted to, so our main office is in Michigan, and I wanted to expand. I actually think our business team is great. We recruited a lot of great talent. We have great research talent for Michigan as well. We have a lot of like Harvard AI scientists that came out, but now we want to like kind of play in like extensively. We have to build like I think Austin's official executive, right? Official. Like even coming out of that, I guess there's a lot of people like hungry to learn. I mean, it's really I just don't see that. All right. Yeah, go to Latin. Check out our I do know that oh yeah, I mean, so cool. When I was I dropped out to start my company. Really? That's worked out but it's like I was open source. My neighbor is actually 6'9". My neighbor's unbelievably tall. It's like this buddy where we do like this block party. My wife's also really tall. Everybody's going the same direction. It's wild when I see names because 6'10", I kind of smell like you're getting close to like a foot taller than me. My background's like yeah, he's like standard or and he's fucking out some of the correct. So I started the framework company around narrow models actually mimicking yes, sorry. So it's just something different, and I think Austin has that DNA against the grain. Do something different.
Do you have a sense?
I'm a friend who's actually got here last night. A couple days ago. Kind of exploring yeah, absolutely. Yeah.
Well, you know, this is.
I could went to Google one of the 2 I'm doing quite a lot in Austin, so work a lot.
some other things that I think
There's not really a lot of AI companies here. But yeah,
Slave chain, the thing I did there, so code I mentioned it.
Sarah, you know Sarah Tyler? She's on the Robotics Academy. She's a director of communications. Yeah, she was Facebook. She was Facebook's director. She was yeah. So she actually joined us. I thought you were going to learn something. We're really focused on like the AI aspects. We're a lot of risk opportunities. We just got nice now. We've been big down.
No, exactly.
7 years since I joined. 3 years of that. David, yeah, Scout. We're doing all these, some things called virus, but the product is being publicized. It's still in vital, but we have some like tech efforts. And then it usually is. Some of the Bay Area. So I'd say Bay Area, about 50%, under 50% of the Bay Area. Kind of the classic role layers. We have Tiger G2BP, which is the environmental fund that Higher Perkins owns. So it's Higher Perkins and that Google I'm on LinkedIn. Absolutely. It's always good that those that don't maybe we grab coffee sometime. They'll learn about it. Nice to meet you. You get a message.
Did you have a question? I just wanted to, I was curious about how you ended up in Austin.
Oh, yeah. Yeah, basically, I planned to come back here for a while. And, the hard part was I was going to quit my job because pre-pandemic, I couldn't work for a while. And I finally, like, after being in the Bay Area for 10 years, I decided, okay, we're just gonna eat it. I'm gonna quit my job. I interviewed at Indeed. I interviewed at Indeed. Actually, I didn't interview. I set up an interview, and the day before I interviewed, they rescinded it because it was a pandemic hit and there was chaos, right? So they canceled my interview, and I was so disappointed. Like, we bought a house here and everything, and I was like, okay, well, I don't have any interviews in Austin. I bought a house in Austin, so yeah, it was a disaster. But yeah, I bought a house and finally collapsed. I mean, now like Austin's coming back. I lost money like when it collapsed. It's not, yeah, that was like a rough deal. But then like a week later, Facebook said, "Oh, you're not allowed to come back because of COVID." And I was like, "Well, we have this house in Austin, so I moved." And then about a year later, I got permission to work remote. And I worked remote for Facebook until
But you've got fun.
yeah. Well, that was one of the things, and also, I wanted a warm climate. I wanted to be, I also have family in Florida, so I wanted to be closer to Florida. I debated, my wife and I debated moving to Florida, but we decided Austin's kind of good in between, where the infrastructure here is really good, the schools are good, there's a good amount of tech jobs, and so it's a happy medium between California and Florida, and geographically.
How much AI activity is there? About 16. Is there startups in that space?
I think it's growing a lot. I think we're seeing a lot of people who are really excited and just getting on the latest thing. And you're seeing a lot of like new wave energy. Like I saw it with crypto. I've been very cynical of crypto, but I did appreciate like all the energy that was in Austin. Right? And so now you're starting to see the energy shift over to this LLM, which is, hey, great talk.
Hi, great talk. Do you know Kyle Wilson?
Yeah, he's working with us on his contract.
Awesome. Yeah, I work with him on a lot of accounts.
He's always got this football uniform in the background. Like, it's hard when you're on Zoom, but I get the impression when I meet him in real life, it's going to be this huge huge event.
He used to play in the NFL.
What, really?
Yeah.
Oh, really?
One of our sales guys.
What position did he play?
Linebacker. The Bears. Yeah. And now he sells machine learning software.
That's amazing. Wow.
Are you guys based here, or?
In SF.
This is
It's just me and Claire and I think one other person will live in mainly SF. What about yourself?
well, I appreciate that.
We all work remote. All of us.
And Jason.
There's a handful, or like actual folks don't want an office. So there's really only maybe like three, maybe like at the most 6 people who want an office, and that's just not enough to get an office.
Yeah.
You know, if we got up to like maybe 20 or so who want to go in an office.
Yeah, I went to EC. Yeah, I was in the EC department for grad school.
Yeah, if I got a WeWork, no one
Only about a year and a half. A little bit, year and a quarter. Before that, yeah. That was at a company, a robot boost pack, similar machine learning.
Back when we had Argo,
And then I was at a startup here in Austin.
I set up
So I only work for startups like Series C-ish. But it's fascinating space. Oh yeah.
So they were at home the rest of the week, so I think this time I'm going to be much more hesitant to like get some office space.
Yeah.
And nowadays people are expecting
Right.
they're used to it.
There's definitely like
so teaching law, do the students, are they using ChatGPT? Like, are you
people who are fresh out of college?
You incorporated that
they
into
need a tutor.
or Band-Aid
Yeah,
or what's
no, but it's just so hard getting
Right.
other people.
And if somebody uses it to kind of.
Jason, right?
Yeah.
I really like your speech, you know, you're well spoken.
I saw somebody
Programmers who are actually like, I know are really well spoken, I really like that. Who can,
So I may be wondering.
normies.
All right.
Yeah, I'll reach out to you and see if,
Cool.
you know, maybe as a test case, I could try building a thing. I can't promise anything, 'cause it's, you know,
So did
version
you
0
kind of,
thing, but,
did you know that